I'm Abby, and I am back on Twitch, and I'm here with Ian from the Aurora team, who launched something very special today. Ian, welcome.
Thank you very much.
Can you tell us a little bit about what you launched?
Yeah, so we launched what's called Aurora Backtrack. And Backtrack gives you the ability to restore your database in seconds. So if there are catastrophic errors, you can go back to up to 72 hours in the past and have a fresh copy of your database. And it also gives you the ability not just to do a one-time restoration, but you can move forward and back in time in seconds to determine the right point at which to say, this is where we're restoring back to.
So even if I had a backup that was like part of the way, I could figure out which the actual correct place that I wanted to restore to was?
Yeah, so what's really different about Aurora Backtrack is that it isn't working with traditional backups or traditional sort of snapshotting mechanisms. It's actually rewinding the state of the database to a point in time so that you're instantaneously available to use the system as it was at that point.
Also part of this launch, I made a very funny share joke on Twitter, which I was the only one that appreciated, but it was funny.
Excellent.
Other than the obvious, which is everyone should have backups and they should have backups that work, why would I want to use this?
Yeah, so most of the time we see the need being that you're going to have a catastrophic failure of your database and you need to be able to very, very quickly get back to where you were and have that super fast failure recovery. So for mission critical systems where you don't want to take the time to do a restoration to a snapshot database and then replace the tables. So this might be because you drop a really sensitive table in your environment and you just need to go right back to the point that it was dropped. And also one of the use cases that we're imagining is it'll be great for doing sort of testing environments where you want to be able to spin up an environment that is your test system, apply a set of changes through your application, and then be able to snap that back to a point in time so you can rerun tests and be able to automate that kind of workflow.
So I know you mentioned that it wasn't working kind of the same way as traditional backups, which are generally snapshots. Can you tell me a little bit about how it works and why kind of the rewinding mechanism is different than what we've seen before?
Yeah, indeed. So the first thing to understand is really Aurora storage is really quite different than other types of databases. And I might show you a picture as a place to start. We showed this yesterday when we were talking about Aurora serverless. So the nature of Aurora storage is that instead of having a database with disk drives attached to the database, and then for high availability, moving database transactions between instances, with Aurora storage, we use a shared storage volume that sits across availability zones, and then instances within our AZs attach to that storage and do really interesting stuff. And so Aurora storage works very differently. It's what we call a log-structured storage system, which means that all of the changes that are being made to the database are being progressed over a period of time, okay? So Backtrack is really interesting because it takes advantage of this log-structured storage to be able to orient the log-oriented storage around this particular point in time. So for example, if you had a timeline of changes that were being made, and in this example, T0 is kind of when we started using our database, and then we apply changes as we go. And we make changes up to point T1. Well, at some point we then say, hey, look, I'd really like to rewind back to that point in time because it gave me something that I needed to demonstrate. Then what we can do is issue this backtrack command. Okay, and what that does is it reorients the system back to that original T1 point in time. Everything after that point in time is invisible. It's still in the log structure storage, but from there we can continue to make changes, and those will happen at the original timestamp that we've got, so T2, T3, and so on. And we can do that as many times as we need. So if we then say, look, okay, we've made some data changes, some data fixes, and now we want to have subsequent changes made, we can rewind again and again in order to get to the point that we're happy with the point in time.
Which makes it a lot more flexible as opposed to the traditional way, which is either I am restoring from my snapshot and maybe you take a snapshot every 12 hours or every 24 hours or every 36, but that's kind of get what you get. You either have to restore the whole thing or you don't restore, so
Yeah,
now
so
it's a little bit more flexible.
Indeed, in the relational database service, all of our database engines support what are called point-in-time recovery snapshots. So down to 5 minutes of granularity, you're able to back up that database to another location. You choose within a 5-minute window where you want to get to. What's really different about Backtrack is that where a snapshot has to be restored into a new database, and then you bring in the changes to your production environment, with Backtrack you do it right over the top of the cluster.
Gotcha.
So you're able to snapshot back extremely quickly without having to go through that restoration process.
So a question from Twitch, how quick does this backup get restored, and how does this work with read replicas? Will the read replica always be on the same T as the master?
Yeah, great question. So the backtracking time will be somewhat dependent on the size of your instance.
Right.
Our observation is it takes between 30 and 60 seconds to do the backtracking. It also affects all of the read replicas, so this is a cluster level operation. You are backtracking the entire system to a point in time. You can then adjust that forward and backward as needed, but it does affect the entire cluster.
I heard a rumor that you have a demo.
I do.
So demo time.
Yeah, wicked.
Demo.
Very good. So it's kind of a demo. It's more like a video because it's a video. But wanted to give you a sense of how this thing works, and we'll walk you through what's happening in this, this demo video. So in this example, we're going to show that there's a table. It's a simple table called T1. And it's got a couple of columns, and then we're going to go in and drop it. So this would be, you know, if something happened and accidentally we dropped a table and we didn't mean to, and we can see here that table was in fact dropped. We're then going to go into our instance within the RDS console, and we're going to backtrack this database cluster back to a point in time that we know that table existed. In this case, we're backing it up just a few minutes to a point in time. And the UI is fairly straightforward. You just set the point in time that you want to backtrack to, and then you issue the command. Now the instance and all of the read replicas at this point are being backtracked so that the primary will have detached from the storage. It will then back itself up to that point. We did shorten that sequence just for the purposes of showing how it works. And then we go in and we can see that, in fact, this table has now been restored to its original state. One other thing that's important to highlight is that in between, while the system was backtracking, it does have to reset all connection states because it goes back to the last valid transaction time before the backtrack time. And so you will see that your clients reconnect. In this case, that happens automatically. It's a MySQL database and a MySQL client, so it's just reconnected, and then we can see that table's back as though it had never been dropped.
And you could see that in the UI where it basically said that your database will briefly be unavailable during the backtracking process.
Correct.
So it has to reset the connections as well.
That's right. That's right.
Awesome. Cool. So
Good.
I love live demos.
Yeah.
I had a question from Twitch also that was, are there any plans to support this with Aurora Postgresql?
Yeah, so you know, we're certainly looking at what features people are looking for between the two different systems. So the RDS service as a whole supports Oracle, SQL Server, MySQL, MariaDB, and Postgres as engines. Aurora storage is available for MySQL and for Postgres as engines. So for those of you at home, you know, and the two different engines are really very useful for different sorts of use cases, and also just on the basis of what applications you have. You know, certainly the team is always looking for you know, feedback on what features people want, and you know, certainly we've heard the feedback loud and clear that being able to do very, very fast restores is important, and so I'm sure we'll look to introduce this into other engines in future.
So I know that, getting back to kind of the why is this different, I know that RDS has point-in-time recovery snapshots, which I think are more the traditional kind of way of doing backups with the snapshot. Does this replace this, or how do I differentiate between like snapshots and these backtracks?
Sure, yeah, it's an important point to keep in mind, which is that, so Backtrack is available for up to 72 hours in the past, whereas point-in-time recovery snapshots are available for up to 35 days of retention period, and you get to set the retention period for both of these features when you configure your database, and they can be modified after the fact as well. But they are really for different use cases, and certainly the long-term ability to create new systems, to have daily backups that go back to a month, for example, is quite different than the Backtrack feature. In the future, we'll look to expand that Backtrack time window, but for today, we're launching at 72 hours. So that's a big difference, and then also the granularity. With Backtrack, you can go back to any valid transaction point in that 72 hours, whereas point-in-time recovery snapshots are every 5 minutes, which is still quite granular, but in the case of a live system where you need to backtrack to a specific change, this is a really important feature.
Do you see people using in production kind of a combination of these right now? So like Backtrack to rewind to a more granular point in the last 72 hours, but some snapshots from later periods.
Yeah.
Just in case, for example, maybe someone drops production database.
Yeah.
Maybe they didn't mean to, maybe it happened anyway.
Absolutely, so you should consider using these as an overall strategy for backup and recovery. And when we reason with customers about how should they design a backup and recovery strategy, we think about the recovery point objective, or RPO, and the recovery time objective, the RTO. And these are really important things for you to think about in your production systems, to talk to your end users and your stakeholders and say, well look, if we were to have a catastrophic failure, how long should it take us to restore to a point in time, and what is that point in time? Everybody wants to have a RPO of zero possible losses on the system, and ideally an RTO of 0 as well. Backtrack makes an RTO of around 60 seconds with an RPO of virtually 0 possible over the top of your system, but only within 72 hours. If you look at changes where you might need to go back even further, then that's where you would use the point-in-time recovery snapshots. But they're going to have a different recovery time because you have to restore them into a new database, and then you have to propagate the changes into the primary, and then the recovery point, of course, is only going to be within 5 minutes of granularity. So you absolutely want to use both, but we think that this Backtrack window is something that will really complement and allow you to bring that RPO right down to a much shorter window.
I think it's important to note also that the only acceptable kinds of backups are the ones that you actually know worked, and that's maybe the strongest reason to go for like a managed backup system, is because you know that they work. Yeah. And that like everyone has that situation where they're like, oh, of course I have backups, and then the day that you need the backups, you're like, it turns out that my snapshot is from 72 days ago, and that's not a very helpful backup.
Yeah, that's right, yeah. I mean, certainly with point-in-time recovery snapshots, testing periodically that you can bring those up, and then you run sort of game days to reconnect your applications and to say, look, if we did need to reconnect, how long would it take, even run fire drills all the way up to the point where you activate that. With Backtrack, you do have the ability to clone databases. It's another one of the quite powerful features of Aurora storage, which is that we can almost instantaneously create a brand new database with a different name, but whose contents are the same as the primary. If that database was enabled for Backtrack logs, then you can simulate that on the clone, and that's quite an interesting way to look at it.
It feels really nice and interesting, something that's gotten really popular recently, which is chaos engineering, which used to be kind of like a Netflix thing and like a really brave company thing, but now it sounds like with something like Backtrack, I could probably include that in like my chaos engineering testing so that I could have the exact same content with a different name, but I could use it to actually simulate in real life what happens when my database goes.
Yeah, I mean, I think it's really important to be very comfortable and to have tested the failure semantics of your database and your application more generally, and certainly databases are traditionally an area where once changes are made, they're very difficult to reason about. So, certainly in the case of your testing pipeline, I think we see Backtrack as being an incredibly useful feature, which is you can inject and simulate failures like total database corruption, drop tables, drop databases, and so on. And this is kind of a complement to Aurora's wider features around being able to simulate things like network failures. So you can say, well, what would this database run like if I was to inject an AZ partition? And these are commands that you can run within an Aurora database to do that kind of testing.
Yeah. So I have two little questions. So one, what's the pricing on Backtrack?
Yeah, good question. So when you create a new database with Backtrack enabled, then we expose a new set of CloudWatch metrics, which are these Backtrack change records, and we meter per million of the change records per hour. And so there's a price. And here in London, it's 1.4 cents per million change records per hour. And the best thing to do is to, if you think that this feature could be really interesting for you, go in, take a database that has, a production-like workload or a test and dev workload, and then look at these CloudWatch metrics around millions of change records, and that will give you an indicative cost.
Gotcha. Is it in GA and where can I use it?
Yeah, it is.
Everyone's favorite question.
Yeah, as of this morning, it's in global availability for MySQL 5.6, and you can use it anywhere that Aurora is supported. So it's an Aurora feature for MySQL, and you can take advantage of this on all new databases that you create.
Awesome. So I guess my last kind of question for you is, I know we talked a little bit about increasing the window that I could use Backtrack from. What do you see as kind of being next for Backtrack? What do you think people will really enjoy getting out of it? What do you think you want to build next?
Yeah, so I mean, I think that the time period that people want to be able to backtrack to is the interesting one, and we're going to learn a lot from how people use Backtrack in early days. Certainly expanding to other distributions, so certainly support for MySQL 5.7 is coming very, very soon. And then from there, we're going to listen to our customers, and we're going to build the features that are asked for. That's kind of in our DNA. So do you have a guess maybe on what you think people will be asking for? Because I know it seems like a more granular backup solution is something that everyone would want, but can you think of customers that would be particularly excited about using something like this, or a particular space in their workload where you think you see people really wanting to use it? Yeah. So one that we're watching very closely is kind of the dev and test workloads and how customers use, for instance, our code deploy and code pipeline tools to do builds of their software and then run integration tests, and how Backtrack can fit into that and really look for feedback. And then certainly how we're seeing it used in production in particular. New features, we'll see what customer feedback comes in.
I like the idea of implementing that right into code pipeline, so that as part of my kind of building and testing process, I tested the database too, which is pretty much what I'm doing.
That's a good idea.
Yeah.
That's a good idea. Maybe we can suggest that to the team.
So if you're on Twitch and you have any last questions for us, we have Ian for just a couple more minutes, and then we will be signing off for the day. Some cool stuff about Aurora today, though. I had never actually really thought about doing more flexible backups than that. So and I wish that we had something like that when I was running production databases, because definitely have messed them up.
Yeah, so yesterday we talked about Aurora Serverless, which is a really exciting feature to be coming in the next few months. And sometimes it's kind of hard to get excited about something. Serverless sounds fantastic, but when you really look at something like backup and restore, it is absolutely what you live and die by in terms of your business being successful, your application stack working over time. And so we do get really excited about it, and would encourage everybody who's listening, really do go deep and look hard at your backup and recovery strategy. It matters just as much on the cloud as it would in any other type of environment. And certainly being able to simulate it with the idea of chaos engineering is really, really important.
That's the backups are a thing too that you never really want to think about until you really are having a really large backup emergency problem.
Yeah.
So better to think about it in small bits now and then not have to think about it later than get to a point where you're like, I don't know if my snapshot works, and then you find out it definitely doesn't.
Yeah, absolutely.
Not that that's happened to me in real life, ever.
No, as our CTO says, Werner Vogels, everything fails all the time, and it's best for you to look at your environment and know what happens when it fails, as opposed to letting it come up and surprise you. So certainly testing these things and being comfortable that your operations teams and your development teams are going to be clear on what their process is, should they need to hopefully never take advantage of one of these features. But certainly we think Backtrack makes it very, very straightforward that you can snap that whole system back.
It's like insurance. You don't want to have to think about it until you really need it, and then you want it to just work.
That's right, yeah. But you definitely want to be sure you have it.
I have one more question from Twitch, and it said, is it wise to install Aurora DB on a RAID system?
Okay, so Aurora is a managed service that's available on the relational database service, and the question would be, would you put Aurora on like a RAID storage? Well, in fact, Aurora is only available on the AWS cloud as a managed service, and the whole purpose of using Aurora storage is that it's highly available within a region, so that even if you have whole data centers and availability zones that you want to be able to fail away from or scale horizontally, that you can take advantage of that in the cloud. So you would run that through the RDS service.
So yeah, so just to clarify, you don't install Aurora yourself.
Correct.
It's a managed service from AWS, and
yeah, that's right. And we take responsibility for provisioning the database and the hosts. We scale that database horizontally if you ask for that. We do all the patching, and of course we do the backup and recovery should you need it.
Awesome. Well, Ian, thank you very much. I think we have 2 more special guests joining us. Just to close out our Twitch coverage today. Ian, Adrian, hello.
Hello. So, thanks for doing the last session, guys. That was great.
That was
and
brilliant.
Thanks for joining us from the AWS Summit in London. You can see the team, like me, are now getting tired and jaded. They're ready to run off and do something relaxing for the evening. Hopefully not breaking down the expo
That was a
behind
great
us.
2 day, though. It was awesome.
It was an awesome 2 days. Super busy on Twitch today. Thank you everyone for joining us. It was really fun. And we'll be back streaming all kinds of content all the time.
Be sure to subscribe and follow us on Twitch.
Yeah.
Get those lovely push notifications when we go live. Got also all kinds of different content on the channel, both live events like you've seen here today, but also live coding and interviews and other content with members of the team here at AWS as well. So there's a lot of stuff that you can catch up on if you have the time and want to learn more about AWS in the cloud.
And if you want to see something special, don't hesitate to send us a message and ask for it. We're happy to do things.
Find us all on Twitter as well, and we'll take your feedback there. Any suggestions or feedback you might have.
That's great.
I think we're all on, including the elusive Mr. Myers at the end there, occasionally active on the little blue bird.
That's right.
Great stuff. So we'll see you next time. Thank you.
Thank you.
Okay, thank you.
See you guys.